The topic that we have today is rate of reaction. Okay. Now, what exactly is rate? Does anyone know what rate is or how we measure that? The idea of rate is that whatever reaction happens, it produces something. Some change is going to happen. That change can be really fast. For example, when a rocket is launched or a space shuttle is launched, a very explosive reaction happens between hydrogen and oxygen. We control how that happens so that we are able to control how the space shuttle moves or what speed and everything. But at the same time, there are some reactions that are really, really slow. For example, rusting of an old car. It takes a really long time for the car to rust. Okay. Especially if it is in a dry situation or something. There are factors that affect how fast or slow something happens. And it is important for us to be able to control or at least understand that so that we can get whatever we want out of it. So, for that, to understand it, we have collision theory. Okay. Collision theory says that, first of all, particles have to collide for any reaction to happen. Okay. So, there are two requirements for this. So first of all, it says for a successful reaction, for a reaction, reactant particles must collide with sufficient energy and at the correct angles. Or a better word for this would be correct orientation. So if I want particles to react, they must collide with the correct orientation. It's like, let's say you have a pen and you have a cap and you want to put the cap on the pen. Now, the cap must have, so if this is a pen and this is a cap, then sure, you can move the cap like this and it will cover it. But if you rotate the cap, if the cap was like this, then no matter how much you move it, it will never close the pen. It will never cover it up. Only the correct angle will allow you to cover it up. So that's the first idea, that when particles collide, they must collide with the right or the correct orientation at the correct angles. Second, they must collide with enough speed so that they are able to overcome the barrier. What is that barrier? The barrier is activation energy. So their energy must be greater than activation energy so that they can go over that and they can collide with the right reaction. If they don't have correct energy, what will happen? They will collide and they'll bounce off. For example, if hydrogen comes and collides with chlorine and it doesn't have the right energy, there won't be any reaction. It'll just bounce off, just like a ball bounces off a wall. But if they collide with the correct orientation and the correct energy, it can produce HCl. Okay. What form of energy is activation energy? It is kinetic energy. So it is the minimum kinetic energy. So activation energy is the minimum kinetic energy that particles must collide with to collide successfully. And what do we mean by colliding successfully? We mean that the reaction occurs. If the reaction does not occur, we say it's not a successful collision. Okay, so far we know that collision theory says for a reaction to happen, reactant particles must collide with sufficient energy and at the correct orientation. In O levels and IGCSE, we don't spend a lot of time on orientation. We don't worry about it too much. What we do talk about is how the particles energy is there and whether we can affect that energy somehow, or whether we can affect the number of particles that happens. So how does this all relate to rate? Rate is the product per unit time. We want to affect the rate, but collision theory says that rate depends on frequency of successful collision. You can say frequency of successful collisions, or you can say number of successful collisions per time. Both of those will be acceptable and they will affect the rate. So what is rate? Rate is the change that happens in the reactants, in the amount that you measured, to figure out compared to the time. That is rate. Rate is the change, the increase or decrease in products or in the reactants per unit time. That's the idea. I'll get to it in a bit, that how do we change or measure the rate. But for now, let's talk about collision theory. How can we affect the frequency of successful collision? Now, first thing that you need to know for that is कि frequency of successful collision है क्या? Let's suppose there are 100 collisions that happen. One option is that, let's say there is 10% of those collisions are successful. So 100 collisions happen, 10% are successful. If I want to increase the successful collision, then what I can do is that I can increase it from 10% to 12% or 15%. That is one option. Let's say in 100 collisions, 10% is successful. That's 10 collisions. But if I do 1,000 collisions, then I have 100 successful collisions. So overall, I've increased the number of collisions. That's one option. One option is that I increase the percentage. That I still do 100 collisions, but I increase the proportion of successful collisions in that. That word is important. The proportion of successful collision. So if 10% is successful, I do something to make it 15% or 20%. Second is I keep the 10% there, but I increase the total collisions that happen. जहां 100 में से 10 सक्सेसफुल होनी है, मैं 1000 collisions करा देता हूं, 100 सक्सेसफुल हो जाएंगी. So that is still a bigger number, right? Even though percentage is same, the proportion is same, but I get more successful collision. That's another option. And third option is that I check out that what is stopping every collision from being successful. That's activation energy, right? I change the activation energy. So I have all these methods of increasing the proportion of successful collisions or increasing the proportion of particles that have enough energy to collide successfully. So the first factor that we have to do that is temperature. Now, temperature is something you can control for the substance, not for individual particles. What do you do for individual particles? When you increase the temperature, you increase their kinetic energy. And through kinetic energy, you increase the proportion of particles with enough energy. And that is how you increase the frequency. So with temperature, you have provided them with kinetic energy. And through that, you have increased the proportion of energy. So obviously, if there are 50 particles that had successful collisions, now you're going to get 75 particles that have successful collisions. So obviously, the frequency increases, the rate increases. So in temperature, you're giving them energy, and because of that, they're crossing the barrier more easily. And not just that, more of them are crossing the barrier. That is important. The proportion of particles, the number of particles out of total that are able to collide successfully is more. Okay, that's one. So the barrier is still there, but the temperature allows more particles to jump the barrier. The second factor that you have is pressure. Pressure means the force per unit area. When you increase the forces with which particles collide, now again, the proportion of particles with enough energy increases. And this again affects the frequency of successful collision. But for this to happen, there are many ways of doing this. One is you decrease the volume. When you decrease the volume, particles come closer. The proportion of successful collisions happens more. Why? Because when they are closer, they collide more. You haven't given them more energy. It's just that पहले अगर 100 collision हो रही थी, अब 200 collision होंगी. और अगर पहले 10% successful थी और total 100 थी, तो कितनी successful collision थी? 10% of 100, 10 collisions. But now if you have 10% of 200 collision, you have 20 collisions. So you have more collisions that are successful. So pressure affects the particles that are able to move around, and that is only gases. So pressure only affects gases. And that affects the frequency of successful collisions. The third factor that we have is surface area. What surface area does is that, for example, you have your notebook. Let's say your notebook is closed. So only the outer boundary, the top page, the side, this side, and the bottom page, they are exposed. So if a particle has to collide, it can only collide on those surfaces. But if you open the notebook, now you still have the sides, but you have not just this portion, but you also have this portion. You have more area exposed for collision. So now the particle can collide here, here, here. It has more area where it can collide. We say that the surface area is higher. So when the surface area is higher, particles are able to collide more. So basically, surface area exposes more particles at the same time. And when it exposes more particles, the frequency of successful collision increases. The next factor that we have is, okay, let's say I can't affect how many particles, how many successful collisions are there. Let's say वो अभी भी 10% ही. But 100 collisions are happening. What if I have more particles? मैं particles ही add कर देता हूँ. So अब 10% ने collide करना है ना successfully. मैं particles ज़्यादा कर देता हूँ तो overall collision will still be higher. पहले अगर 50 particles collide कर रहे थे, अब 100 particles collide करेंगे, the number of collision will still be more. So that factor is called concentration. But remember one thing, it's not concentration itself that affects the rate of reaction. Hidden inside concentration is another factor, which is number of moles. It is number of moles actually that affects the rate of reaction. If you have more moles, more collisions are going to happen. But concentration helps us do it in the same volume. I will explain this point in a little bit. So it's technically the number of moles that affect the collision, but time को concentration से फर्क पड़ता है. अभी मैं बताता हूँ कैसे. So it increases the number of particles, so that increases the frequency of successful collisions. And last factor is very interesting because this is a factor that does nothing to the particles. Temperature gives kinetic energy to particles. Pressure makes them collide more. Surface area exposes them. Concentration increases the number of particles. But there's one factor that doesn't do anything to the particles. It doesn't give them energy. It doesn't bring them together. It doesn't increase their number. All it does is it affects the barrier that they must cross. It lowers the barrier. That is catalyst. So what catalyst does is lowers activation energy. So now proportion of particles with enough energy is more. This point is very important. This point. That it is the proportion of particles which is more that allows it to be increased. And this is collision theory. It simply says that you have to increase the frequency of successful collision. One option, you give the particles more energy, so there's a greater proportion that can overcome the barrier. Second is you make them collide more through pressure. Third is you expose them to collisions, so more proportion is affected. Fourth is you increase the number of particles so that they collide more at the same time. And final is you reduce the barrier. In all of this, proportion of particle with enough energy gets more, frequency of successful collision is high, rate increases. Okay. So all of that is there when it comes to the rate. And this is collision theory. Any question on this? Now the next thing is, how do we measure the rate? So whenever you're measuring rate, we have a graphical method. There are two ways technically. There's one that is graphical method and one that is tabular method. I'll talk about both of them. So in the graphical method, what we do is that we take one thing, that we can measure after intervals. So we take a variable and we measure it after time intervals. Okay. So we obviously take those measurements. We're able to make a graph by first taking the time in seconds or minutes. And that variable can be volume of gas, that can be mass in grams, that can be concentration, that can be temperature, that can be a number of different things. Anything that changes during a reaction can be used here. Once we have that, we draw the graph. The two main methods that O levels and IGCSE people use is volume of gas and mass versus time. So I'll show you graphs of both of them. So if you have a gas volume, that could be in cm cube or dm cube, and if you have mass, that could be in grams. इस साइड पे आपके पास टाइम ही रहता है, वो मिनट्स में भी हो सकता है, वो सेकंड्स में भी हो सकता है. अच्छा, अब जब आपके पास गैस वॉल्यूम है तो शुरू में तो रिएक्टेंट आपके पास प्रोडक्ट में गैस आ रही है, लेट्स सपोज शुरू में तो गैस है ही नहीं, तो वो जीरो से स्टार्ट होगी और आहिस्ता आहिस्ता वो इंक्रीज करती जाएगी और एक टाइम आएगा कि वो एक फिक्स वैल्यू पे पहुंच जाएगी. सो अगर मैं इसको देखूं तो ये ऐसे करके ग्राफ बनेगा. दिस इज द टाइम when the graph becomes constant, when we say that equilibrium is established. अब वो equilibrium हो सकता है कि वो रिएक्शन खत्म हो गया हो, इस वजह से इक्विलिब्रियम एस्टैब्लिश हुआ है, या हो सकता है कि इक्विलिब्रियम वैसे एस्टैब्लिश हो गया हो इन अ रिवर्सिबल रिएक्शन. लेकिन ये हमेशा जीरो से स्टार्ट होता है बिकॉज शुरू में आपके पास प्रोडक्ट नहीं होता. द सेकंड ऑप्शन इज कि आप मैस की कोई फिक्स वैल्यू लेते हो कि अच्छा मेरे पास ये रिएक्टेंट्स हैं, ये मैस प्रोड्यूस कर रहे हैं, तो उनकी कोई वैल्यू हाई होती है और उससे वो नीचे आते हैं और इनकी वैल्यू ऐसे करके इंक्रीज करती है, डिक्रीज करती है, सॉरी. एंड नोटिस दैट इट नेवर रीचेस जीरो. व्हाई? बिकॉज ये जो मैस है ना, जिसको ये मतलब जहां पे रुक नहीं रही, ये मैस है, मैस ऑफ इक्विपमेंट और एक्सेस पार्टिकल्स. कि मतलब आपने एसिड को मेटल से रिएक्ट कराया, मेटल आपका एक्सेस में, एसिड सारा यूज हो गया, हाइड्रोजन गैस प्रोड्यूस होगी, लेकिन वो जो एसिड रिएक्ट नहीं किया या जो मेटल रिएक्ट नहीं किया वो तो पड़ा रहेगा. सिमिलरली आपका बीकर है, उसके एक वॉल्यूम है, आपके पास वाटर है, उसका एक मास है, वो सारे का सारा यहाँ पे आएगा, ये कभी जीरो पे नहीं जाता. ओके, सो आई हैव द मास ऑन वन साइड, गैस वॉल्यूम ऑन द अदर साइड. रेट कैसे पता चलेगा? रेट वी विल मेजर थ्रू द टेंजेंट. व्हाट्स अ टेंजेंट? टेंजेंट इज a line that cuts the curve at only one point. So let's suppose मैंने यहाँ पर rate देखना, so I'll draw a tangent here. But tangent का gradient मुझे कैसे calculate करना है, ये आपने math में सीखा होगा through the triangle method. You pick any 2 points. Let's say मैं एक point ये pick कर लेता हूँ, एक point ये pick कर लेता हूँ. The point here, I'll join them. Technically, I'll just have a triangle here. और इस ट्राइंगल का ग्रेडियंट पता करना है मुझे. There are many names that we give to this. This gradient is called slope. This gradient is called gradient. And interestingly, इसका एक फॉर्मूला भी होता है, y2 minus y1 over x2 minus x1. और वो क्या है? बेसिकली मैं कहता हूँ कि ये पॉइंट y2 है, ये y1 है, ये x2 है, ये x1 है, और मैं कहता हूँ कि ये डिस्टेंस विच इज टेक्निकली x2 minus x1, तो इसको मैं बोल सकता हूँ कि दिस इज द बेस ऑफ द ट्राइंगल. सिमिलरली दिस डिस्टेंस, दिस इज माय y2 minus y1, इसको मैं बोल सकता हूँ दिस इज द हाइट ऑफ द ट्राइंगल. I can say that this is height over base. Does anybody recall opposite over adjacent को क्या कहते हैं मैथ में? किसको याद है? Some people have curly brown
Sine.
hair. Sine is opposite over hypotenuse. यहाँ पे मेरे पास opposite over base है. Through proper brushing. Tan. tan theta through proper brushing,
Cos.
perpendicular over base, right? So ये इस triangle का tan theta है. We have so many names for this. और चूंकि the line is getting a smaller and smaller angle और its height जो है वो कम होती जा रही है, the gradient also decreases over time. So the rate decreases over time because reactant particles are used up. वो है ही नहीं तो कोलाइड सक्सेसफुली कैसे करेगा उतने टाइम में? And that is how it changes. ठीक है? So we can measure the rate through this. तो हम ग्राफ बनाते हैं, हम वैल्यूज मेजर करते हैं और फिर हम उनको देखते हैं कि अच्छा इसका ग्रेडियंट क्या है, और जैसे जैसे ग्रेडियंट कम होता जाता है उससे हमें पता लग जाता है कि रेट कैसा हो रहा है. अच्छा, अब ये जो सारे मैंने फैक्टर्स बताए थे, हाउ डू दे अफेक्ट द ग्राफ, इसके लिए मैं आपको ग्राफ की कुछ एग्जांपल्स करवाता हूँ. ये मेरे पास एक लेट सपोज ओरिजिनल ग्राफ मेरा, ये मैंने पर्पल में ड्रॉ कर दिया. दिस इज अ रिएक्शन दैट्स हैपनिंग, गैस वॉल्यूम है इन cm क्यूब एंड टाइम के साथ ये हो रहा है. I'm calling this my original graph number 1. Remember one thing. The y-axis is about the output. The y-axis depends on moles. अगर आप moles ज्यादा करेंगे, y की वैल्यू ज्यादा हो जाएगी. यानी कि जहां पे जाके ये फ्लैट हो रहा है ना, वो वैल्यू ज्यादा हो जाएगी. अगर आप y कम करेंगे, और सॉरी, अगर आप मोल्स कम करेंगे किसी भी रिएक्शन में, तो y की वैल्यू कम हो जाएगी. तो मोल के फॉर्मूलाज हमें ज़हन में रखने चाहिए. मोल किस पे डिपेंड करता है? मास ओवर एमआर. मोल डिपेंड करता है वॉल्यूम ओवर 24 डीएम क्यूब पे, वॉल्यूम ऑफ गैस. या मोल डिपेंड करता है कॉन्सेंट्रेशन टाइम्स वॉल्यूम. ये तीन चीजें हैं जिन पे मोल्स डिपेंड करता है. तो अगर आप इनमें से किसी को भी, मास को, गैस वॉल्यूम को, कॉन्सेंट्रेशन को या वॉल्यूम ऑफ सॉल्यूशन को कम करेंगे, तो ये कम होना चाहिए. मोल्स कम हो जाएंगे, मोल्स कम हो जाएंगे तो रिएक्शन कम गैस प्रोड्यूस करेगा. अगर आप कहीं पे भी मोल्स इंक्रीज कर देते हैं, मैं मैग्नीशियम का रिएक्शन करा रहा हूं, मैं मैग्नीशियम का मास ज्यादा यूज करता हूं, तो नंबर ऑफ मोल्स ज्यादा हुए, मोल ज्यादा हुए, तो मेरा ग्राफ हायर वैल्यू पे जाके फ्लैट होएगा. ठीक है? तो वाई वैल्यू को चेंज करने के लिए आपको क्या करना है? मोल्स को चेंज करना है. और कोलिजन थ्योरी में जितने फैक्टर्स हैं, टेम्परेचर, कैटलिस्ट, सरफेस एरिया, प्रेशर, all of those affect the time. So all 5 factors affect time. तो अगर टेम्परेचर बढ़ाएंगे टाइम कम लगेगा, टेम्परेचर कम करेंगे टाइम ज्यादा लगेगा. क्यों? कोलिजन. लेकिन उसका वाई पे फर्क नहीं आएगा, क्योंकि वाई तो मोल्स पे डिपेंड करता है. आपने टेम्परेचर बढ़ाया तो मोल तो नहीं चेंज हुए, वाई की वैल्यू चेंज नहीं होगी. सही है? दिस इज अ वेरी इंपॉर्टेंट पॉइंट, ये ज़हन में रखना. अगर आप मोल्स चेंज नहीं कर रहे हो तो इसका मतलब है कि y की वैल्यू चेंज नहीं होगी. सो लेट मी कंसीडर दीज पॉइंट. लेट सपोज मैं टेम्परेचर बढ़ाता हूं तो माय कर्व विल गो अप, मतलब इस वाली कर्व से ये ऊपर को रहेगी. लेकिन विल इट गेट अ बेटर वैल्यू ऑन y, अ बिगर वैल्यू ऑन y? नो, बिकॉज व्हेन यू इंक्रीज टेम्परेचर आप मोल्स चेंज नहीं करते हो, तो मोल चेंज नहीं हुआ तो उसने उसी पे आके फ्लैट होना है, बस वो जल्दी फ्लैट हो जाएगी. आप टेम्परेचर कम करते हो, ये मेरी ग्राफ नंबर 2 है. आप टेम्परेचर कम करते हो या प्रेशर कम करते हो या कैटलिस्ट नहीं ऐड करते हो या सरफेस एरिया ज्यादा कम कर देते हो, यानी कि बड़ा पार्टिकल यूज करते हो, तो आपने टाइम को ज्यादा कर देना, लेकिन मोल को आपने नहीं छेड़ा. सो ये नीचे से आएगा, सॉरी, but it will go to a same level of the flat line. मोल्स उतने ही हैं, इस वजह से ये थर्ड ग्राफ उतना ही आउटपुट देगा, हाँ टाइम ज्यादा लगेगा इसको। सिमिलरली अगर मैं कॉन्सेंट्रेशन बढ़ाता हूं तो मैंने मोल्स बढ़ा दिए, जब मैंने मोल्स बढ़ाए तो मेरा ग्राफ जो है वो अब तेज होगा, लेकिन साथ ही साथ मोल्स बढ़ाने की वजह से वो फ्लैट भी हायर लेवल पे जाके होगा क्योंकि मोल्स बढ़ा दी। सो ग्राफ का एंगल कम या ज्यादा होना डिपेंड करता है कि वो कोलिजन थ्योरी के 5 फैक्टर्स में से क्या चेंज हुआ, लेकिन वाई पे वो फ्लैट कब होता है ये डिपेंड करता है कि उसमें मोल्स आपने ज्यादा किए या कम किए। नाउ इज एवरीबॉडी क्लियर कि लेट सपोज मैं इस ग्राफ को देखता हूं तो इस ग्राफ में मैंने मोल्स कम किए होंगे, ऐसे ही है, मतलब ये मेरे पास फिफ्थ लाइन है। इफ यू लुक एट द फिफ्थ लाइन, लेट्स कंपेयर फर्स्ट फोर्थ एंड फिफ्थ। सबसे ज्यादा मोल्स किसमें? फोर्थ
The
में।
fourth one.
यस, दैट इज बिकॉज इट माइट हैव द ग्रेटेस्ट concentration because it's also the fastest. सबसे कम मोल्स हैं 5 में between these three, and that clearly shows that 5 is slower, 1 is faster, 4th is the fastest. But what if I get something like, I want you to compare the first and the sixth one. Which one is slower?
Sixth one.
Sixth one is slower. That definitely means कि concentration कम हुई है, या temperature कम हुआ है, या pressure कम हुआ है, या surface area ज्यादा हुआ है और कम हुआ है, लेकिन मोल ज्यादा हो गए। Is there a way to increase the moles while decreasing the concentration? Look at these formulas.
By diluting it.
If you dilute anything, you add water, which means moles do not change. The concentration does. जिसका मतलब है कि वो स्लो होता लेकिन आता उसी 1 वाले लेवल पे इफ यू ऐड वाटर। इसने कुछ और किया है, मोल ज्यादा किए हैं लेकिन कॉन्सेंट्रेशन कम किया है। कैसे? बाय इंक्रीजिंग द वॉल्यूम। क्योंकि फॉर्मूला देखो ना, N इक्वल CV, कॉन्सेंट्रेशन एंड वॉल्यूम दोनों पे डिपेंड करता है मोल्स। तो अगर मैं कॉन्सेंट्रेशन कम कर दूंगा तो रिएक्शन स्लो तो हो जाएगा, लेकिन अगर मैं वॉल्यूम बढ़ा दूंगा तो मोल ज्यादा हो जाएंगे। वो एंड हायर लेवल पे करेगा चाहे वो थोड़ा सा स्लो होके करे। दिस इज अ वेरी टेक्निकल पॉइंट, ठीक है?
Sir, can you explain this one again?
Sure. Remember, the value on the y where the graph becomes constant is dependent on the moles of products made, which depends on the moles of reactants that you have. So moles पे फर्क पड़ता है. But how fast or slow the rate is depends on all the 5 factors that we have. So if you increase any of those, the graph is faster. If you decrease any of those, the graph is slower. In this graph between first and sixth, sixth is slower. That means temperature, surface area, pressure, concentration, ये सारे के सारे इसमें कम है compared to first, क्योंकि first तेज है. But at the same time, sixth is producing more volume. That means sixth has greater moles. The only way that you can reduce the concentration and yet have greater moles is if you add more solution. आपने 10 cm क्यूब डालना था, आप 20 डाल दो। हाँ, उसकी कॉन्सेंट्रेशन कम कर दो, तो अब पार्टिकल्स ज्यादा हैं लेकिन वो दूर दूर हैं, तो उनकी कोलिजन अभी भी ओवरऑल कोलिजन ज्यादा ही होंगी लेकिन ज्यादा टाइम में भी होंगी, तो वो स्लो हो जाएगा। क्लियर?
Yes, sir.
Perfect. So it's a really short topic and we are done with the ideas here.